Hi there, this is Lila at Inquiry into Morals by Robert and Pirsig, and I'm reading chapter 11. Phaedrus throttled the engine back to a fast rumbling idle. Then he headed the boat up into the howling wind, which caught the sail and cracked it like a whip. He dashed forward and freed the halyard. He pulled the sail down as fast as he could, furled it with a single stop, and got back to the tiller again before the boat lost its heading. Crazy wind. Damn gale through here. Why didn't they tell him about this in Castleton? Phew! The water was full of whitecaps and spray. He should have seen that before he reached it. He wasn't paying attention. He unclidded the toppling lift and lowered the boom into its gallows notch, then sat down again. With the sail down and the engine guiding the boat, everything now seemed under control. Storm King Mountain loomed over him to the right, and Breadneck Ridge to the left. Up ahead was West Point, and the dogleg in the river called World's End. Apparently this wind was some sort of funnel effect from the mountains. After a while, he saw that the wind wasn't getting any worse. It just seemed to hold at a mild gale force. He'd bought this boat with the illusion that when you sailed, you just sat and admired the scenery. It seemed like he hadn't sat still for 5 minutes in all these days without something needing attention. Now he saw that he'd furled the sail too sloppily, and it was blowing loose. He tied the tiller, went forward again, and this time got all the sail tucked in properly, and the stops carefully knotted. He wondered why Lila was still below somewhere and hadn't reacted to all this. He supposed he could have gotten her up here to take the tiller while he fixed the sail, but something told him it would be easier just to tie it off himself. She wasn't the aye aye sir sort of crewman you needed for jobs like this. Up ahead were waves caused by the change in the direction of the river. The water looked angry at having been forced to change its path. As he approached, he saw it boil up from below and whirled around in strange eddy currents. He headed the boat away from them. Everything he said turned out wrong with her. No point in aggravating the situation any further. She lived in another world, she really did. And you could never break into this world by superimposing on it patterns of your own. What he told her about the head boat was valuable if she had been listening, but she wasn't. She wasn't a listener. She had a set of fixed static patterns of value, and if you argued with her, she'd get mad at you and maybe spite you in some way, and that's about all. He'd seen enough of that. He'd been bucking that stuff all his life. At the south entrance to the military academy, the wind died down to a mild breeze. The boat passed under the high castle-like walls, and he thought of calling Lila up to look at it, but he decided he better not. She wouldn't be interested. After a while, the academy was out of sight, and the wind started to pick up again into a sailing breeze. He decided not to put up the sail. The day was running on. He felt tired now. The engine could do it from here. He sure didn't feel like going anywhere tonight. All he wanted to do was sleep. Does Lila have quality? There it was again, Rigel's infuriating question. It would come back again and again like that until he had an answer for it. That was the way his mind worked. Why did he ever answer yes? She seemed determined to prove Rigel was right. He shouldn't have given any answer at all. Does a dog have a Buddha nature? It's the same question. It's exactly the same question. You could transpose it right into that whole Zen verse by Mumon. Does Lila have quality? That's the most important question of all. But if you answer yes or you answer no, you lose your own quality. That's a perfect transposition. That's exactly what happened. He answered yes. That was his mistake. He let himself get caught into the kind of picking and choosing situation that Zen avoids. And now he was stuck. It wasn't that the question wasn't answerable. It was answerable, but the answer went on, and you never got done. It isn't Lila that has quality. It's quality that has Lila. Nothing can have quality. To have something is to possess it, and to possess something is to dominate it. Nothing dominates quality. If there's domination and possession involved, it's quality that dominates and possesses Lila. She's created by it. She's a cohesion of changing static patterns of this quality. There isn't any more to her than that. The words Lila uses, the thoughts she thinks, the values she holds, are the end product of 3.5 billion years of the history of the entire world. She's a kind of jungle of evolutionary patterns of value. She doesn't know how they all got there any more than any jungle knows how it came to be. And yet, in the middle of this Lila jungle are ancient prehistoric ruins of past civilizations. You could dig into those ruins like an archaeologist, layer by layer, through regressive centuries of civilization, measuring by distance down in the soil, the distance back in time. That was an intriguing idea. You could structure a whole analysis around this one person, interview her, find out what her values were, and then show the entire metaphysics in terms of one specific case. This whole metaphysics was crying for something to bring it down to earth. You could ask her questions all the way to Florida. He thought about it for a while. It would be an ideal interviewing situation. What could she tell him, though? Those patterns might be there, but she doesn't know what they are. She'd just sit there and tell him about her typing and her head boat and all the different kinds of food she likes and complain about the coffee, and he wouldn't get anything. Some trip that would be. Something else sounded wrong, too. It was too contrived, too full of objective, observational stuff. It ignored the whole dynamic aspect. There is always this open end of dynamic indeterminacy. It would be impossible to predict anything from what she said. Also, she didn't think much of him. She probably wouldn't tell him anything, just like the Indians and the objective anthropes. Dusenberry should be here. He could get it out of her. All I'm good for is theory, Phoebus thought. But the theory was okay. Lila is composed of static patterns of value, and these patterns are evolving toward a dynamic quality. That's the theory anyway. She's on her way somewhere, just like everybody else, and you can't say where that somewhere is. The theory had arrived in his mind several months ago with the statement, all life is a migration of static patterns of quality toward dynamic quality. It had been boiling around in his mind ever since. In traditional subject-centered metaphysics, life isn't evolving toward anything. Life's just an extension of the properties of atoms, nothing more. It has to be that, because atoms and varying forms of energy are all there is. But in the metaphysics of quality, what is evolving isn't patterns of atoms. What's evolving is static patterns of value. And while that doesn't change the data of evolution, it completely upends the interpretation that can be given to evolution. Historically, this assumption by a subject-object metaphysics that all the world is composed of substance put a strain on the theory of evolution right from its beginning. At the time of its origin, it wasn't yet understood that at the level of photons and electrons and other small particles, the laws of cause and effect no longer apply. That electrons and photons simply appear and disappear without individual predictability and without individual cause. So today, we have as a result a theory of evolution in which man is ruthlessly controlled by the cause and effect laws of the universe, while the particles of his body are not. The absurdity of this seems to be neglected. The problem doesn't lie in anyone's department. Physicists can ignore it because they are not concerned with man. Social scientists can ignore it because they are not concerned with subatomic particles. So although modern physics pulled the rug out from under the deterministic explanation of evolution many decades ago, it has survived by default because no other more plausible explanation has been available. But right from the beginning, substance-caused evolution has always had a puzzling aspect that it has never been able to eliminate. It goes into many volumes about how the fittest survive, but never once answers the question of why. This is the sort of irrelevant-sounding question that seems minor at first, and the mind looks for a quick answer to dismiss it. It sounds like one of those hostile, ignorant questions some fundamentalist preacher might think up. But why do the fittest survive? Why does any life survive? It's illogical. It's self-contradictory that life should survive. If life is strictly a result of the physical and chemical forces of nature, then why is life opposed to the same forces in its struggle to survive? Either life is with physical nature or it's against it. If it's with nature, there's nothing to survive. If it's against physical nature, then there must be something apart from the physical and chemical forces of nature that is motivating it to be against physical nature. The second law of thermodynamics states that all energy systems run down like a clock and never rewind themselves. But life not only runs up, converting low-energy seawater, sunlight, and air into high-energy chemicals, it keeps multiplying itself into more and better clocks that keep running up faster and faster. For example, why should a group of simple, stable compounds of carbon, hydrogen, oxygen, and nitrogen struggle for billions of years to organize themselves into a professor of chemistry? What's the motive? If we leave a chemistry professor out on a rock in the sun long enough, the forces of nature will convert him into simple compounds of carbon, oxygen, hydrogen, and nitrogen, calcium, phosphorus, and small amounts of other minerals. It's a one-way reaction. No matter what kind of chemistry professor we use, and no matter what process we use, we can't turn those compounds back into a chemistry professor. Chemistry professors are unstable mixtures of predominantly unstable compounds which, in their exclusive presence of the sun's heat, decay irreversibly into simpler organic and inorganic compounds. That's a scientific fact. The question is, then why does nature reverse this process? What on earth causes the inorganic compounds to go the other way? It isn't the sun's energy. We just saw what the sun's energy did. It has to be something else. What is it? Nowhere on the pages of all that he had read about evolution did Phaedrus see any answer. He knew of theological answers, of course, but these aren't supported by scientific observation. Evolutionists, in their reply, simply say that in the scientific observations of the facts of the universe, no goal or pattern has ever appeared toward which life is heading. That last statement so neatly sweeps the whole matter under the carpet, one would never guess that it was of much concern to evolutionists at all. But reading of the early history of the theories of evolution shows this is not true. The first major evolutionist, who was not Darwin, but Jean-Baptiste Lamarck, maintained that all life was evolving toward perfection, a synonym for quality. Alfred Wallace, who forced Darwin to publish by independently arriving at an almost identical theory, also maintained that natural selection was not enough to account for the development of man. After Darwin, many others continued to deny the goallessness of life. Phaedrus had found a good summary of the entire matter in a Scientific American article by Ernest Mayr. Those who rejected natural selection on religious or philosophical grounds, or simply because it seemed too random a process to explain evolution, continued for many years to put forward alternative schemes with such names as orthogenesis, nomogenesis, aristogenesis, or the omega principle of Teilhard de Chardin, each scheme relying on some built-in tendency or drive towards perfection or progress. All these theories were finalistic. They postulated some form of cosmic teleology or purpose or program. The proponents of teleological theories, for all their efforts, have been unable to find any mechanism, except supernatural ones, that can account for their postulated finalism. The possibility that any such mechanism can exist has now been virtually ruled out by the findings of molecular biology. Evolution is recklessly opportunistic. It favors any variation that provides a competitive advantage over other members of an organism's own population, or over individuals of different species. For billions of years, this process has automatically fueled what we call evolutionary progress. No program controlled or directed this progression. It was the result of spur-of-the-moment decisions of natural selection. Mayr certainly seemed to consider the matter settled, and this attitude no doubt reflected a consensus among everyone except anti-evolutionists. But after reading it, Phaedrus wrote on one of his slips, "It seems clear that no mechanistic pattern exists toward which life is heading, but has the question been taken up of whether life is heading away from mechanistic patterns?" He guessed that the question had not been taken up at all. The concepts necessary for taking it up were not at hand. In a metaphysics in which static universal laws are considered fundamental, the idea that life is evolving away from any law just draws a baffled question mark. It doesn't make any sense. It seems to say that all life is headed towards chaos, since chaos is the only alternative to structural patterns that a law-bound metaphysics can conceive. But dynamic quality is not structured, and yet it is not chaotic. It is value that cannot be contained by static patterns. What the substance-centered evolutionists were showing with their absence of final mechanisms or programs was not an airtight case for the biological goallessness of life. What they were unintentionally showing was a superb example of how values create reality. Science values scientific patterns. Its business is to search for them. When nonconformity appears, it is considered an interruption of the normal rather than the presence of the normal. A deviation from a normal static pattern is something to be explained and, if possible, controlled. The reality science explains is that reality which follows mechanisms and programs. That other worthless stuff which doesn't follow mechanisms and programs we don't pay attention to. See how it works? A thing doesn't exist because we never have observed it. The reason we have never observed it is because we have never looked for it. And the reason we have never looked for it is that it is unimportant. It has no value, and we have better things to do. Because of his different metaphysical orientation, Peter saw instantly that those seemingly trivial, unimportant, spur-of-the-moment decisions that Mayer was talking about, the decisions that directed the progress of evolution are, in fact, dynamic quality itself. Dynamic quality, the source of all things, the pre-intellectual cutting edge of reality, always appears as spur of the moment. Where else could it appear? When this prejudice gets spur of the moment, dynamic quality is removed, new worlds of reality open up. Naturally, there is no mechanism towards which life is heading. Mechanisms are the enemy of life. The more static and unyielding the mechanisms are, the more life works to evade them or overcome them. The law of gravity, for example, is perhaps the most ruthlessly static pattern of order in the universe. So correspondingly, there is no single living thing that does not thumb its nose at that law day in and day out. One could almost define life as the organized disobedience of the law of gravity. One could show that the degree to which an organism disobeys this law is a measure of its degree of evolution. Thus, while simple protozoa just barely get around on their cilia, earthworms manage to control their distance and direction. Birds fly into the sky, and man goes all the way to the moon. A similar analysis could be made with other physical laws, such as the second law of thermodynamics. And it seemed to Phaedrus that if one gathered together enough of these deliberate violations of the laws of the universe and formed a generalization from them, a quite different theory of evolution could be inferred. If life is to be explained on the basis of physical laws, then the overwhelming evidence that life deliberately works around these laws cannot be ignored. The reason atoms become chemistry professors has got to be that something in nature does not like laws of chemical equilibrium, or the law of gravity, or the laws of thermodynamics, or any other law that restricts the molecule's freedom. They only go along with laws of any kind because they have to, preferring an existence that does not follow any laws whatsoever. This would explain why patterns of life do not change solely in accord with causative mechanisms, or programs, or blind operations of physical laws. They do not just change valuelessly. They change in ways that evade, override, and circumvent these laws. The patterns of life are constantly evolving in response to something better than that which these laws have to offer. This would at first seem to contradict the one thing that evolutionists insist upon most, that life is not responding to anything but the survival of the fittest process of natural selection. But survival of the fittest is one of those catchphrases like mutants or misfits that sounds best when you don't ask precisely what it means. Fittest for what? Fittest for survival? That reduces to survival of the survivors, which doesn't say anything. Survival of the fittest is meaningful only when fittest is equated with best, which is to say, quality. And the Darwinians don't mean just any old quality, they mean undefined quality. As Mayer's article makes clear, they are absolutely certain there is no way to define what that fittest is. Good! The undefined fittest they are defending is identical to dynamic quality. Natural selection is dynamic quality at work. There is no quarrel whatsoever between the metaphysics of quality and the Darwinian theory of evolution. Neither is there a quarrel between the metaphysics of quality and the teleological theories which insist that life has some purpose. What the metaphysics of quality has done is unite these opposed doctrines within a larger metaphysical structure that accommodates both of them without contradiction. The river is opening up now into a broad lake that the chart beside Phaedrus identified as the Tappensee, like the Zuiderzee, he supposed. Nice that they had kept the old Dutch name. He turned and looked behind him, and there was the mountain range that he'd passed through. The last range, the American continent, was coming to an end. Soon this strong, heavy boat would be out in the Atlantic for the first time, where it really belonged. That felt exciting after all these weeks. The boat was built to cross oceans and circumnavigate continents, not just run the buoys down placid inland waterways. It was still early afternoon. The boat was making ferocious speed. He supposed that contraction of the river by the mountains must have made it speed up. Now, according to his calculations, the tide would begin to reverse, and it would be slower going. Anyway, that migration of static patterns toward dynamic quality he'd been thinking so much about seemed to hold up so far. In the past, when ideas like it had been defeated, they were always knocked down by the assumptions of a conventional metaphysics of substance. But with the metaphysics of quality behind it, it stood up. He tried dozens of times to think of how it could be knocked down with one argument or another, but he never found anything that worked. And so in the months since it had emerged, he had tried to work out various refinements. The explanation of life as a migration of static patterns toward dynamic quality not only fitted the known facts of evolution, it allowed new ways of interpreting them. Biological evolution can be seen as a process by which weak dynamic forces at a subatomic level discover stratagems for overcoming huge static inorganic forces at a superatomic level. They do this by selecting superatomic mechanisms in which a number of options are so evenly balanced that a weak dynamic force could tip the balance one way or another. The particular atom that the weak dynamic subatomic forces have seized as their primary vehicle is carbon. All life contains carbon, yet a study of properties of the carbon atom shows that, except for the extreme hardness of one of its crystalline forms, there is not much unusual about it. In terms of other physical constants of melting point, conductivity, ionization, and so on, it does just about what its position on the periodic table of the elements suggests it might do. Certainly, there's no hint of any miraculous powers waiting to spring chemistry professors upon a lifeless planet. One physical characteristic that makes carbon unique is that it is the lightest and most active of group 4 atoms, whose chemical bonding characteristics are ambiguous. Usually the positively valence metals in groups 1 through 3 combine chemically with negatively valence nonmetals in groups 5 through 7, and not with other members of their own group. But the group containing carbon is halfway between the metals and nonmetals, so that sometimes carbon combines with metals and sometimes with nonmetals, and sometimes it just sits there and doesn't combine with anything. And sometimes it combines with itself in long chains and branched trees and rings. Phaedrus thought this ambiguity of carbon's bonding preferences was the situation the weak dynamic subatomic forces needed. Carbon bonding was a balanced mechanism they could take over. It was a vehicle they could steer to all sorts of freedom by selecting first one bonding preference and then another in an almost unlimited variety of ways. And what a variety has been chosen! Today, there are more than 2 million known compounds of carbon, roughly 20 times as many as all other known chemical compounds in the world. The chemistry of life is the chemistry of carbon. What distinguishes all the species of plants and animals is, in the final analysis, differences in the way carbon atoms choose to bond. But the invention of dynamic carbon bonding represents only one kind of evolutionary stratagem. The other kind is preservation of what has been invented. A dynamic advance is meaningless unless it can find some static pattern with which to protect itself from degeneration back to the conditions that existed before the advance was made. Evolution can't be a continuous forward movement. It must be a process of ratchet-like steps in which there is a dynamic movement forward of some new incline, and then, if the result looks successful, a static latching on of the gain that has been made, then another dynamic advance, then another static latch. What the dynamic force had to invent in order to move up the molecular level and stay there was a carbon molecule that could preserve its limited dynamic freedom from inorganic laws and at the same time resist deterioration back to simple compounds of carbon again. A study of nature shows the dynamic force was not able to do this, but got around the problem by inventing two molecules, a static molecule able to resist abrasion, heat, chemical attack, and the like, and a dynamic one able to preserve the subatomic indeterminacy at a molecular level and try everything in the ways of chemical combination. The static molecule, an enormous chemically dead plastic-like molecule called protein, surrounds the dynamic one and prevents attack by forces of light, heat, and other chemicals that would prey on its sensitivity and destroy it. The dynamic one, called DNA, reciprocates by telling the static one what to do, replacing the static one when it wears out, replacing itself even when it hasn't worn out, and changing its own nature to overcome adverse conditions. These two kinds of molecules, working together, are all there is in some viruses, which are the simplest forms of life. This division of all biological evolutionary patterns into a dynamic function and a static function continues on up through higher levels of evolution. The formations of semi-permeable cell walls to let food in and keep poisons out is a static latch. So are bones, shells, hide, fur, burrows, clothes, houses, villages, castles, rituals, symbols, laws, and libraries. All of these prevent evolutionary degeneration. On the other hand, the shift in cell reproduction from mitosis to meiosis to permit sexual choice and allow huge DNA diversification is a dynamic advance. So is the collective organization of cells into metazoan societies called plants and animals. So are sexual choice, symbiosis, death and regeneration, communality, communication, speculative thought, curiosity, and art. Most of these, when viewed in a substance-centered evolutionary way, are thought of as mere incidental properties of the molecular machine, but in a value-centered explanation of evolution, they are close to the dynamic process itself, pulling the pattern of life forward to greater levels of versatility and freedom. Sometimes a dynamic increment goes forward, but can find no latching mechanism and so fails and slips back to a previous latched position. Whole species and cultures get lost this way. Sometimes a static pattern becomes so powerful it prohibits any dynamic moves forward. In both cases, the evolutionary process is halted for a while. But when it's not halted, the result has been an increase in power to control hostile forces or an increase in versatility, or both. The increase in versatility is directed towards dynamic quality. The increase in power to control hostile forces is directed towards static quality. Without dynamic quality, the organism cannot grow. Without static quality, the organism cannot last. Both are needed. Now, when we come to the chemistry professor and see him studying his empirically gathered data, trying to figure out what it means, this person makes more sense. He's not just some impartial visitor from outer space, looking in on all this with no purpose other than to observe. Neither is he some static, molecular, objective biological machine doing all this for absolutely no purpose whatsoever. We see that he's conducting his experiments for exactly the same purpose as the subatomic forces had when they first began to create him billions of years ago. He's looking for information that will expand the static patterns of evolution itself and give both greater versatility and greater stability against hostile static forces of nature. He may have personal motives such as pure fun, that is, the dynamic quality of his work, but when he applies for funds, he will normally and properly tie his request to some branch of humanity's overall evolutionary purpose.